Join us. Thank you for staying for the last lap of this race. It's always the best competitors who are in the last lap, so consider yourselves one of the better competitors in the race to a smart city. My name again is Gordon Feller with Meeting of the Minds. I also have a role at Cisco headquarters in Silicon Valley, so I'll bring both a build the collaboration perspective to this, as well as a technology company worried about the future of smart cities perspective. And let me introduce my colleagues who are joining me for this last panel session. We are going to look at the fourth smart city pain point of the day, and that's in the realm of transportation systems and mobility. As I said before the break, it's historically the first realm of connectivity for cities. Back in the Tigris and Euphrates Valley, when in Mesopotamia the first cities emerged in human history, the first connectivity inside the city and between cities was in physical transportation, often on the rivers, which is why those first cities were river-based cities. To my right is Hiro Sakai, and he's with the Railway Technical Research Institute in Japan, a part of the Japan Railways organization, one of the world's largest rail companies, and certainly one of the most innovative, not just in technology, but in organizing and financing the growth of rail systems in Japan and elsewhere around the world. To his right is Dr. Blair Rubel, Vice President of the Woodrow Wilson International Center for Scholars at the Smithsonian Institution in Washington, D.C. He also serves as the Director of the Urban Sustainability Laboratory inside the Wilson Center in Washington. And to his right, we have Bob Dieter. Bob is based in Australia. He's Vice President for Strategic Opportunities at Cubic Transportation Systems, which is headquartered in San Diego, but he's here in the Asia-Pacific region. So we're going to start, as I said before the break, with a question about failure of systems. We know what it looks like when there's a failed system in the energy realm. We have a blackout, and maybe worse. In the water realm, we know, I'm from California very well, what happens when water systems are not able to deliver the goods and make those services possible for residents and consumers as well as enterprise consumers. And we obviously had just a moment ago a session about what happens when the cybersecurity defenses fail and malicious actors hijack information systems, access data that should be secure and private, and the possibility of critical infrastructure in all of those categories: energy, water, transport. Well, we have a real living example in Washington, D.C., and possibly in other cities that we can talk about, but I'm going to ask Blair to start us off with a picture of what happens when an urban transportation system fails, and what are the sources of those failures. A lot of cities in the emerging economies and a lot of cities in the global north are suffering from severe traffic congestion, surface transportation breakdowns, partly because of growth, partly because of other sources of problems. And hopefully some of our discussion today will unearth some of the secret sauce, not just for the success stories, and we'll hear, for instance, from Japan about how successful mass transit has been and what the future might look like, particularly intelligent transportation systems that are powered by intelligent data. But we'll also try to unpack the secret sauce, the recipe for failure as well as success. So we'll start, since the last panel was a bit sobering about risk, we'll start with the sobering story of what's happened in the Washington metro system and how it potentially provides lessons for all of us. Blair?
Thank you, Gordon. Gordon asked what happens. Basically what happens is people can't move. They can't move around the city. That means they seek out other ways of moving around the city, usually driving, which produces other forms of congestion. But the Washington case is particularly dramatic because what happened is passengers have been killed. They've been killed by trains crashing into one another. They've been killed by fires on tracks, all of which were preventable. So the question becomes, how can a system which 40 years ago was a world standard and technological advance collapse? And we're at the point now where major sections of the Washington metro system are closed for weeks at a time to be rebuilt. Well, part of the reason for this is a governance failure. Transportation systems are among the largest systems that will be built, and they'll become obsolete under the best of circumstances during the time that people depend upon them. That means there has to be constant management, constant renewal of the system. There has to be constant investment. Well, the first thing that happens, and it happened in New York 40, 50 years ago, it's not unique, but the first thing that happens is politicians love to show up when something new comes online. They can, they cut the ribbon, everybody's lined up, they smile, they're very proud of themselves. In democracies, they can go out and they can pat themselves on the back when they try to get reelected. But they don't really like paying for maintenance because nobody sees maintenance. And when you have to cut corners because transportation systems are expensive to run and nobody wants a tax increase, well, we'll just cut a corner here or there in maintenance because nobody will notice. Until one day, two trains run head-on into one another because nobody kept the signal technology up to date. And that happened in Washington 4 or 5 years ago. A number of people were killed. Another thing that happens, procurement. We've had a spate of fires with the cables connecting tracks. And it's interesting, news reporters in Washington have called up in New York and asked, how often does this happen? And it never happens in New York. They didn't know what they were talking about. But in Washington, they were bought on the cheap, poorly installed, and evidently, this may be urban legend, but evidently at some point, Metro didn't want to pay overtime to the lowest wage workers in the system, the people who go out and clean the tracks. So garbage piled up, and you started having fires that have killed people. So that's what happens when there's failure. The origin of the failure is a political problem. There was a great regional political compromise to build the Washington metro system. You have the federal government, you have the District of Columbia, you have 2 states, you have a number of counties, a number of jurisdictions. They came up with a very complicated formula and governance structure in which the governing board is appointed by these various jurisdictions. And all the jurisdictions very rarely are in the hands of the same political party. And what has happened is there's no secure revenue stream. There's no political agreement on what should be done going forward. And there's no accountability because these are appointees of other levels of government. So a culture of unaccountability had grown up in the Washington metro system. Just last week, for the first time, a train director, operator was fired for running a red light. The first time. That's after everything that I've talked about. So transparency, accountability, adequate funding streams, these are the lifeblood of making transportation systems work. And it doesn't matter how high-tech a system is. If you don't get the management structures right, you begin to have to deal with failure. And failure can cost the economy. There are figures that are being calculated on how many millions and hundreds of millions of dollars are being lost in the Washington economy every day that the system isn't fully operative. That's one cost. But there's also the cost of the trauma of the passengers and the personnel who have to live through the experience of some of these disasters. Plus, there have been not large numbers, but there have been people killed. And all of that, of course, erodes what we were talking about in the previous session, which is trust. So it's really important when building these systems, to not just think that you build them and walk away. It's important to understand that you're building a system that is going to constantly need engagement by management and will constantly need funding.
Well, one of the themes that we heard in the first three panels, which I want to address here, is about the long-term investment requirements that infrastructure demands from not only the government, but from the taxpayers who fund the government. And there are some success stories like Singapore, where you have a long-term strategy for building a smart city, and you make investments in that smart infrastructure that enables smart city solutions to work well. This is a case where there were no long-term investments after the end of the Cold War. Can you talk a little bit about the different frame of reference during the Cold War versus what happened after the collapse of the Soviet Union, and how that showed up in the realm of government willingness to finance infrastructure?
Well, I think that this is a more general problem than just the Washington Metro, but I do think that there was, if you will, a hard security constraint during the Cold War. And when it was lifted, people started talking about where will the peace dividend go? Well, it turned out the peace dividend evaporated, because without a sense of threat, people didn't want to pay taxes. There was no compelling vision driving, there was no fear, to be frank about it. And the American investment in a number of things, including transportation infrastructure, but more broadly began to erode because people didn't sense that there were any consequences. And I think that this has been a major challenge in American political life.
Well, the flip side of that story is Japan, is a long-term strategy to build out high-speed rail, to build out intra-urban rail, for instance, within the Tokyo metropolitan region and Osaka and several other major metro regions. Could you talk a little bit, Hiro, about the sort of long-term point of view that Japan Railways has taken, what technology investments have been made over time? What technology? I think that's the Japanese government wanting to interrupt me, but maybe not. What long-term investments have been made in safety and security after the big accident occurred, and how the big accident helped shift the perspective of the senior leadership, both the political leadership and the business of Japan Railways? I think it would be interesting for people to hear that as we talk about smart transportation.
Okay. And our history of Japan Railways is mostly the history of accident for the last 150 years. And not mostly the accident, small accident or incident happen every day somewhere in Japan for the last 150 years. Then sometimes a big accident coming up. Then every time we overcome what happened and how we should manage. Then by hearing your topics this time, what's the most important is training or education to employees. Because if you install hardware or sophisticated or high technology systems, would work. But the most important is you should know, you should realize or understand how railroad or services operation to be managed. You should know the structure of railroad systems. Otherwise, you just install your toy railways into your city. And I came here in Singapore, and yesterday I have time. I enjoy metro system and LRT systems up to the north. The system perfect. Everything automatic, including ticketing and train operation and platform management. You know the reason why? I know the reason. The people over here has no experience of operating railroad systems. Then, in such a case, how they can manage railroad systems? Mostly impossible. In such a case, they have two ways. Okay, we decide to take time to educate their employees, but it takes a long time, 10 years or 20 years, I'm not sure. But if we want to install the metro system immediately, you have to buy the system, everything automatic, like a toy. It's up to you. But mostly you buy such a toy. More safe, more easy.
But it's an expensive toy.
Absolutely. But you know, if you train your employees for a long time, also costly. But in that case, you can get some experience for the future. If something happens, you can imagine that, oh, what happened in this case? And I can manage this time. This is very important. But if you buy a toy to install your city, no experience basically, and if something happens, you have to call the manufacturer engineer to take care. And what you got, no experience. Just you pay. That's it. Then which way you take, it's up to you.
This may not be working, so we'll
Good writing.
use these. So one of the things that do I need to turn it on? Okay, it's on. One of the things that worries me, of course, about the Japan experience is not what Japan Railways is doing, but what the other rail systems are not doing. And of course, the promise of a smart system is the automation of an old infrastructure with a digital overlay on top of that older system. That's the beautiful ideal vision. An old existing light rail system that moves passengers around a metro region, built in the 40s or the 50s, upgraded maybe in the 60s and the 70s, and operated well in the 80s and the 90s. Now in a new century, the hope is that the digital systems overlaid on top of the old physical systems can help extend the life of an old system out maybe a decade or two. Is that an unrealistic vision, or is that something that metro regions around the world should consider as a possibility for their pre-digital systems that they operate today?
Yeah.
I think it's on. Yeah, it's on.
Okay. The question is, metro system should be automatic using the digital data, right? Yeah, mostly needed. Even in Tokyo, the Tokyo Metro company using the digital data to organize. I think that to dispatch trains, they installed such a system 30 years back. Before that, mostly manual. When the accident happened, they immediately change the train schedule by hand. But in such a case, they need experience, should be trained for a long time. But even now, there is such technology handed out to the next generation. This is because if you install data system, but something happened with the system, how do you do? Even in such a case, Japan Railway and the Tokyo Metro can do that. This is because they trained every year by manual operation. It's okay. It's very important. How do you manage your transportation systems stably? Just I said, you install sophisticated systems using digital data. It's one option. Other option should be you should train your employees. The same answer.
Well, this raises a question, of course, about the human factor and the trustworthiness of the digital signal, literally the signal that broke down in Washington. As I look back at the history of urban transportation systems, I think of Cubic and the work that Cubic has done over the decades, because it was an early innovator in deploying automatic systems for toll collection, for fare collection. So it's not a surprise that transportation agencies around the world thought first to invest in advanced technology to make sure that they're collecting 100% of the fare and they're able to bank that money as quickly as possible and to assure their lifeline, in this case, their financial lifeline. And even before I think many of the systems invested in automated safety, they invested in automated money collection. And Cubic was there early days in that revolution in modern transportation. I wonder, Bob, if you could talk a little bit in the role that you and your company play as a trusted advisor to metropolitan transportation agencies and those who operate them, but also as a provider of advanced solutions and then as an integrator helping those agencies integrate new technology. Can you talk a little bit about what you're expecting in the way of those transportation agencies' ability to integrate new technology that may be coming at them, as we've discussed? There's a lot of very advanced, data-rich technology that's coming at these agencies. Many of these agencies are 50 years old, 100 years old. They've been operating for a long time. They have a lot of systems. They run bus systems, they run light rail systems, they run traffic systems, they run toll systems on highways. So they have a lot of different types of businesses that they operate. Can you talk a little bit about your perception of their ability to integrate and adapt to the new technology?
Sure, thanks, Gordon. In listening to Hero and Blair, and I think Blair's a great example. You know, we started in this business in the 70s. Washington Metro was one of our projects. Revenue collection is almost as important as the train running, because if people can't get on the train because, you know, gated systems don't work, well, that's a huge problem. So we're very visible when things go wrong. We have to be very reliable. And part of the challenge with maintenance and cost is that public transportation is basically a revenue loser. In the US, it has to be subsidized. A lot of people don't, if the services aren't great, people don't use it. Cars are cheaper than ever. Getting people to use public transport is not always an easy proposition for people. It's, you know, I'd rather drive my car than get on a crowded train. So the revenue part of it for the operations is critical, that these operations are sustainable. In terms of the technology, when we first started in the business and we were working with these train and bus authorities, many of them had no experience in any kind of IT. So this was the first system where they had collective IT, computerized transactional data coming in basically in real time from these systems, and they didn't even have the staffs back then to even handle it. So we basically worked with them to train them and basically help them bring up their staff to a level of competency that they could interact with us in a meaningful way. As the technology moves faster and faster, it's really hard for them, I think, to keep up with everything that's out there and kind of evaluate what's the best investment they can make, and in deploying it, how does it affect their riders? Because the customer experience is extremely important, and you know, it's not just running a train and, you know, if you decide to get on because it's public transport, it's the folks that we work with that focus on the customer experience are the ones that have the best services. You know, London Underground is probably a really good example of folks that we work with that really started focusing on the customer experience. And, you know, they were pioneers in accepting contactless bank cards in their system. That was a big leap for them. It was a pretty significant leap for us. Open loop, non-proprietary standards, and a new customer interaction to deal with. So these were challenges that they had to take on, and I think they did a good job of it, and they're a great example. But even that now is looking like yesterday's things, and there's so much more as we talk about smart cities and transportation. Our sort of focus has moved beyond just collecting revenue to helping cities optimize their transit networks, use the capacity that's available to them in terms of excess capacity, drive your ridership towards those periods of time or those services that are less than crowded, and reduce congestion on your streets and bring all that together as a smart city solution from a transport, payment, and information perspective.
Is payment the place where you think the early digital innovations are most likely to show up in a transportation system, like Oyster showed up in London? Is that the first frontier for digital innovation and smart mobility in a city?
We see payment as an enabler and an integration point, that if you integrated all transportation payments, you now have the ability to, working with your authorities, to let them create fare structures and tolling costs, road user charging, whatever it might be that's transportation related, to again provide better information and better utilize the assets. So we think payments combined with the information you gain from it, you know, where the traffic is, where the cars are, what time of day they are, can be all pulled together and then used to create a better model for cities.
Well, this is a theme that showed up in other panels, right? So we heard in the first session about energy cost as a driver for digitization and the development of smart grid infrastructure using meters and the growth of advanced metering infrastructure as a way of managing some of the costs. For instance, not having to deploy personnel to go and read a meter. So some of those first innovations in energy were driven by the economics, so too in water. Now we're hearing it here. So Blair, any view on this?
I think there's another point to pick up on, the direction that Bob is heading in. The big fixed transportation systems we've been talking about, the older systems, and older Washington fits in this, were essentially designed to handle a different problem from the way people are going to live their lives moving forward. The problem they were designed to solve is getting people to and from home, between the office and work, or home and the office. We now are entering a world in which what work means is being transformed by smart technology. Relatively simple things like teleworking dramatically changes the effect. But more subtly, and I think we're beginning to see this in the politics around Metro in Washington, it turns out that younger people who have come of age in the digital era think about mobility in a very different way. They're less concerned about how to get to work than how to have a transportation system that can get them home after clubbing at night. And one of the really politically charged issues around the current situation in Washington is that Metro is shutting down earlier in order to allow the repair work to begin. And there's a whole younger group of riders who are really put out by this and are probably actually going to be lost as riders to the system because they think of public transportation as something that you do after work. And they think of, you know, taking a look at their iPhones, and we were talking about this earlier, Bob, using that information as a way to figure out what is the best way for, should I get on the metro, should I drive, should I take an Uber? It's a systemic way of thinking about how you use the city. And that's another way in which smart cities are going to transform how people move around it. And that's not even on the agenda of many transit systems.
But when we talk to city leaders, elected officials, appointed officials, some of them running transportation agencies, some of them running the planning department for the city, they all are very anxious to get access to rider data. So they have some access to rider data from Japan Rail or from some of Cubic's clients or maybe from the Washington Metro, but the millennials and others are now using rideshare and ride-hailing services like Uber and Lyft. And the pressure has been building on those companies to find ways to open that data, anonymize it, and then open it as an accessible file that a city planner or a transportation systems planner can assess where is the demand, who is moving in a trip from point A to point B, how often and at what time, So I can route my buses appropriately and schedule them appropriately. I can decide, if I have funds for a new station, where would that station be based on the data about where the demand is for ride-hailing service like Uber or Lyft. So I know that there's a certain class of user who's not opting to use the public system. They're opting to use a shared private system. And now the question is, if we want to have them with a world in which they have both options that are equally valued, we're not going to get them off of the ride-hailing system and the ride-sharing system because it serves a need, including in the 20-something, 30-something age group, meeting other people. This is a human drive to mate, and you want to meet those people in those circumstances, and that's why they're spending some time out in the evening. So they need multiple options from the public and the private, and maybe quasi-private, quasi-public. And this raises a question, which is, as the private sector steps into the role, as Uber and Lyft are providing instant services that are seamless, the billing systems are seamless, the scheduling is a no-brainer, it's on demand. I don't have to figure out when the bus is coming, I figure out when I want to press the button. So in a world in which that kind of instant demand gets instant gratification, it's really hard for a public transit system to compete with that. So what's the future for public transit in Japan, in the US, maybe in some other countries that you're looking at, Blair, and in multiple environments? Let me start with you, Hiro. What's the future for publicly funded transit systems that depend on rider fares? Is it a bright future? Is it a dark future? Is it an uncertain future? Give us a look ahead.
Hopefully, bright future. To be honest, the ridership information given by the collecting a ticket or the smart card systems is nowadays very important for marketing. But to be honest, such a data is not open to the public in Japan. Then how can I say, the data should be used to fully organize the transportation network in a city. But it's important data for marketing. At this moment, I cannot respond to you on this.
But is the mood in Japan Railways and more broadly that there is going to be national government investment in advanced 21st century infrastructure because of the Olympics or for other reasons?
To organize the higher capacity of transportation services, we use such a data, but that data should be used just within Japan Railways. It's a sort of top secret.
And the national government has no access?
Don't open. And separately, the Japanese government collect the data by themselves, counting the number of passengers or something.
Bob, you're under pressure in some of your local environments to work with the agency on opening their data sets?
We have. A lot of agencies tend to protect their data very closely. And when we talk about our sort of vision of transportation across public transport, and let's say road tolling and road charging, in many jurisdictions you've got multiple authorities. So they've got a set of data and the other authority has another set of data. Well, I'm not sharing my data with you because that's my data. And breaking down those barriers can be difficult to make that happen.
Well, this came in as a question from the audience, and it's appropriate at this moment. What kind of alliance system, data governance structure, data sharing rules have been made to enable data collaboration and data fusion to make that kind of possibility happen? Are you seeing any trends that you can share about this?
I think we're trying to promote the vision of how that should work. And we think that it's the best alternative for city congestion and congestion generally in places where we work, that bringing that data together and using it in a constructive way will have a benefit to the public, and it may, again, help make those public transport services more appealing to people, whether it's the price point or whether it's the availability. But what do you want? You want a safe, secure service that's there when you want it. You know, New York, London, pretty much walk up to a station and there's a train there, or there's a bus running.
This was the question that just got handed to me. Should cities move towards mass transport customization? In other words, where the customer is at the center of the organization of access to various transport assets, as you say, on demand, from where I am to where I need to be. Blair?
I think this is absolutely the direction that we're going to see in the U.S. And you know, Graham had that wonderful chart up about the complexity of cities. Transportation planning is going to be driven by that complexity, and the technology allows a level of engagement with complexity that didn't exist before. I mean, 50 years ago, when you're building the Washington Metro, planners tried to figure out where the route should go. What we're going to see now are much more holistic approaches. There's a very interesting competition the U.S. Department of Transportation ran, which was Columbus, Ohio won just about a month ago or 6 weeks ago. And it was on smart transit. And what was interesting about the Columbus winning bid is it didn't invest in fixed transportation routes. It invested in what is your vision for connecting disadvantaged populations and communities to job sites? And the answer wasn't building light rail or BRT lines. It was putting down kiosks in poor neighborhoods that would allow poor residents who didn't have credit cards to use ride-sharing facilities with cash. That, I think, is the kind of direction transportation is going to go in. There will be a place for heavy rail, for light rail, for buses, but the whole system is going to be much more flexible.
Well, there are various predictions, of course, about where mass transit will evolve. One of those that you should all look up if you're interested is called Personal Rapid Transit, PRT. And there are some experiments. Masdar attempted one of those experiments, and some others around the world have attempted interesting PRT systems developed by companies like Unitrans and several others. None of them have reached scale. They really even haven't gotten very far beyond the experimental pilot phase. But I think it's worthwhile looking at PRT as one of those varieties of options that are going to be available in the best designed cities, in the cities that can compete most effectively for young, creative talent, for multinational companies that want to attract that talent, for the inbound investment that will come with those types of enterprises, making choices about which cities to locate their next laboratory or their next innovation center or their next customer center or whatever kind of facility they might be building in a new city. The question comes to me now about how do you all view the opportunity and the benefits related to the Internet of Things and to real-time data that enables better maintenance, for instance, of JR trains. Is there a move in JR to have sensor-based systems in each train that relay real-time information about the performance and how that system could be optimized, maybe on an automated basis, to ensure that the maintenance is done before the breakdown, in other words, preventive maintenance?
Nowadays, we have an automatic system to reschedule trains just in case of accident or incident happen and delayed. But you said you want to know
if some of these types of advanced sensor-based systems, like GE is installing now on their locomotives and in their aircraft engines, multiple, in some cases, thousands or tens of thousands of sensors that transmit data in real time about the performance of the system. How hot is it? How much gas is being emitted or being used? Is it wobbling and vibrating in a way that would prompt a breakdown if it wasn't maintained at that moment?
You mean the on-time monitoring system, and partially will use it, but not fully.
Or the operator of the system. So it could be passenger real-time data that says how well is the system performing because I'm making a choice about my commute, or it could be the owner and operator of the system who needs to know in real time whether the system is performing efficiently.
Okay, actually I think the Japan Railway has such a real data on passenger number, but they're already scheduled or train. Then you mean if you receive more passengers beyond your expectations, you want to dispatch another train, right?
Real-time data creates the ability to respond to real conditions.
Okay. Train operation mostly impossible. This is because already scheduled. But bus operation would be fine. We dispatch another bus, one or two, additionally, when receiving more passengers using such a data.
Well, this is a trend which I think we all want to watch, which is the ability of system operators who have real hard assets like buses and trains, or who manage facilities like bus stations and train stations or bus shelters at a particular stop. Can they light up those physical concrete and steel assets with intelligent connectivity to the wireless network, or maybe to the fiber network, to allow very high-speed flow of data, not necessarily all of it coming back to the data center, because the idea is that some of that intelligence can be acted upon locally. Instead of it being a cloud computing solution, maybe we call it a fog solution, because it lies lower to the ground. And that intelligence embedded in that asset, in that bus stop, or that rail stop, or that traffic light, or that outdoor street light, or that parking meter, or the parking space itself, all of these transportation assets are now, we're seeing in cities, get lit up, get connected to the network, become activated. Now there's a problem, which is all the data that's streaming out of these now intelligent assets, something or someone has to take advantage of that flow of data and try to capture some value, to go from big data to little insight that's actionable. Otherwise, the data is meaningless. The big data has no value if it can't provide some interesting little insight that then becomes the basis for an action. Maybe it's a new bus. Maybe it's a maintenance call that wasn't scheduled but seems to be necessary. Maybe it's activating a new fare system that is available as a backup if the primary fare system doesn't work as planned. Are you seeing any of this, Bob, in any of the deployments of new technology?
Well, part of the things that we see when we talk to our customers, and there is an emphasis on it, and you mentioned the sensors inside, big, heavy assets, is a focus now towards what they call condition-based maintenance. And that is condition-based maintenance. Essentially, you look at your sensors and you've got an operating band, and as you see heat or vibration start to build up in a moving part, the idea is to actually repair it before it fails, so that you don't go out of service. You make it as a scheduled maintenance call. You've got the majority of the asset or the component life out of it, so it's economical. You're not doing it too soon, but you're not putting the asset out of service and going, okay, your flight's canceled because the bearing failed and we got to call maintenance in. We did it last night. It was at 99%. It was causing a problem. So that's a great thing, I think, for making assets available. And again, it comes back to the system performance, that your flights are on time, your trains are there, your systems work. You're using that real-time data intelligently to make those systems more reliable.
Well, when I sit with city leaders who have transportation agencies that are very often a very big part of the city budget, both on the expense side and on the income side, it tends to be a large number in that city. And of course, it's the front end of the relationship between the city and the citizen. Because the taxpayer who's commuting is expecting to have some benefit from their tax, and what they see every day is the commute experience is either positive or negative. Generally not neutral for some reason. People don't have a neutral view about commuting. They always have a positive or a negative view. So one of the things I hear is that there are 3 pillars. I like to reduce my costs, make my operating more efficient. I'd like to increase my revenues, and I'd like to have a customer experience that's better. Now that's a big demand on an innovation. So it's a problem for the young technology companies and innovators who are stepping up to provide a solution in the transit space, because there's now a very heavy demand being placed on them to work miracles. And it's hard to make miracles happen in the transit and transport world for cities because they tend to be rather capital intensive, equipment heavy, unionized, and not profitable. And that's not a very great formula for highly flexible, highly adaptive systems. But the good news is that innovators are stepping into the cracks like Uber has done and Lyft has done, where the service provision is not available in those spaces, and suddenly we're discovering that it is not about displacing old services, it's about creating a whole new menu of services that we didn't even know existed. And I wonder, Blair, as you're seeing the technology world comes to this old stodgy thing called urban transport, is there a national strategy that emerges? You talked about the U.S. Department of Transportation at the federal level sponsoring this $50 million Smart City Challenge that the city of Columbus, Ohio won. Is there any indicator to you that there's some federal attention at this level that might last the next administration? Because I know Trump will solve this problem.
Well, I won't comment on that, but no, I think that the current Secretary of Transportation has been very innovative, but we're bad at national planning. And this was an attempt, and an important attempt, to have U.S. federal involvement in some of these decisions, but it's not a pattern that plays to our strength. So I think probably the federal government under any administration is going to lag behind for all the reasons you just gave. It's expensive. There are lots of vested interests in not changing things. And at the scale of a transportation system, it's very difficult for individual entrepreneurs to fill the space. Now, we've seen with ride sharing and with companies like Uber and Lyft that it's easier than people thought, and technology has made it easier than people thought, but this is an area where there's a lot of lag time with innovation. The other point I wanted to make is a very interesting phenomenon in Washington, and I think we see equivalent phenomena in other cities around the world. As the data about performance becomes available, non-official agencies and websites can repackage it and make it available. And one of the most useful new websites for using the Washington Metro system is a private site that has a very colorful name involving an old Anglo-Saxon word that cannot be used in this context. But it goes something like, how blank is Metro now? And you go on, and it has all the information about when trains are arriving, where they are. And this is an example also of a kind of internet piracy actually serving consumers. So I think the old monopoly system is breaking down. And this is a theme that we've heard across the day. It's not exactly clear what will replace it in the long run in transportation.
Well, you mentioned the F word, and so let me ask about the S word, in this case S as in Singapore, and that's surveillance. We haven't talked really about the surveillance that tends to be ever present in transit systems. We had a session last about the privacy and particularly the personal identifier type information. Probably the most profound personal identifier information is your face. And as we see when we visit London, CCTV, is ever present in all parts of the transport system of London. And that was a necessary ingredient, the designers and developers of that system said, to deal with the terrorist threat, in that case, from Northern Ireland. So now the question is, Japan Rail, Washington Metro system, and other systems in the US, systems around the world that Cubic is working with, they're all using video surveillance in many different ways. And they're not necessarily promising to anonymize that. They're not blanking out faces, per se. So when Japan National Police is tracking one murderer per year in Japan, they're going in and presumably asking Japan Rail for some of that video surveillance information to see who that is and where they went, when they enter the system, when they exit the system. Dubai did this, I think, 2 years ago with somebody who committed a murder in Dubai, as infrequent as Japan. Can you make a comment of your view about what's going to happen to personal privacy in the intelligent, smart, advanced urban transportation system for cities?
Okay, mostly 10 years ago, we installed a IC card instead of paper ticket, like Oyster card in London. And first a few years, you can check your data on the use of IC card by yourself, but we stop it. This is because our Japan Rail can track specific passengers, where he goes, or something, what time, where you are. Even now, we can track all passengers, to be honest. But this is a privacy issues. Then one of the reasons why we don't open the data to the public is this is a reason. And even now and ever after, the same could be.
The divorce rate was going up, I assume.
What do you mean?
Marriages were breaking apart. Where were you?
Yes. I know.
Blair, anything from your point of view about the future for privacy and smart urban transit systems?
Well, I think in general, in a place like central Washington, D.C., you should have no assumption of privacy. There are so many people looking at who's going where and London is another example of this. I think we're probably past the point when there should be any assumption of privacy in a major public space. And that includes transportation. And it comes up in crime solving where criminals are caught in Washington because of information, including images of their use of the metro system.
Bob, are you hearing from clients about new approaches or a certain attitude that the operator of transit systems bring to the conversation when you're with them?
Well, I can give you two sides of that, and the sort of, well, one comment is millennials probably don't think they have privacy, and they're happy not to. Social media, everything's out in the open. Everything you've done every 5 minutes, your friend put it up there, so everybody knows what everybody's doing. In terms of transit surveillance, CCTV data, never been anything we've been involved in the past, but now we're being asked, okay, how do you make systems even more efficient, and how do you make them less intrusive? Like if you look at Germany, there are no gates in Germany on any rail system. So we've been doing some research on what we call gateless gating. How do you do that? Well, you've got a long-range token in your pocket, or you could use video surveillance to do, video analytics and match your face. If you don't mind, you don't have to walk through a gate, and you can walk through. If you walk through that area and you don't feel like paying and you're a fare evader, well, you have to capture that image and, send them a fine. But that's sort of a way to use video technology and actually make the stations have a more open feel to them. And we're doing some work in that area with the UK government.
I think I saw the Tom Cruise movie version of that, one of his science fiction movies. So we're running out of time, and I guess I want to raise the final question for this panel and the last panel, and it's really looking back at the whole discussion that we've had during the day. Smart cities face, the realization of a smart city vision is confronted with obstacles. There's the financing obstacle, which we know a lot about in the transit realm. There's the technology and engineering obstacle. We know a lot about that in the transit realm. There's the common global open standards and interoperability problem. We know a lot about that in the transit realm. Look at the different types of gauges in rail systems. It was a 150 years ago interoperability problem that the Soviet Union never solved and Russia and Ukraine fight over. So is there something that we haven't heard over the course of this day, over these multiple panels, that you can think of that's maybe an obstacle? Maybe it's in the psychology of the user of the transit system, or maybe it's in the attitude of government toward the infrastructure, or any one of those realms. And I haven't given you a chance to think about this in advance, so I'm kind of putting you on the spot, and I apologize, but I thought it would be an interesting way to end the conversation for the day before we do our wrap-up. Anything that you would want to point out that's maybe a hidden barrier to success in bringing smart data to the world of urban transport that we should keep in mind, maybe we haven't had enough chance today to talk about? Bob, start with you.
Okay, from everything I heard today, I think a really key thing is global data standards for open data, so that somebody said, don't reinvent the wheel, let's make code available, let's reuse what's there. So, as soon as somebody builds two systems, they're going to be different. So if you have open data standards to take information and process it, that's a facilitator, I think, that's important to have. And I think the other thing that I feel is very important is that governments become more proactive in enabling smart technology to come to the fore, and they've got to become more open and more dynamic in terms of implementing, new legislation and creating new policy. And you mentioned Trump and politics. It's got to withstand multiple changes in political parties and be consistent. I think those are the things that would help make it happen.
Those are excellent. Thank you for those two. They're going to withstand the test of time, I think, those two in particular. Blair, anything that we need to keep in mind?
I think we haven't heard enough about humility.
Humility.
Humility. Any future we can imagine at this moment is going to be outdated before we can imagine it coming into being. We are living in an environment which is changing so quickly that we shouldn't really assume we know what the future is. And it's when we talk about the smart city, human beings will be living in cities in ways in which they've never lived in cities before. What exactly that's going to mean is hard to imagine. But we already are living in cities in ways in which our grandparents could never imagine, or our parents. And I think we need a little bit of humility when we start making projections into the future.
Excellent. Thank you for that. And having seen some of your writing about what futurists imagined for the Soviet Union during the heyday of both Stalin and Khrushchev, I think your point of view is well taken there. Hiro, any thoughts about what we should keep in mind as we go forward?
Okay, and for smart city establishment, we have to recognize what is the issues in your city, and then you find a solution. If you overcome your city issues by some specific services or technology in transportation services, your city would be a smart city. Then the recognition of your city issues is first step. And then you install a solution to be applied to such as city issues. And step by step. Otherwise, no resolution coming up. That's my point.
Excellent. Well, I have to say thank you to my three co-panelists here. This has been an outstanding session. I have the unenviable task of trying to provide a summary for 8 hours of discussion today, which I won't do, but I will say a few things about the next steps. So we will be producing for you to see a summary of some of these discussions. Some of that summary will come from the Twitter feed, which we encourage you to take a look at after you've left here today, because a lot of very intelligent comments, suggestions, critiques have come to us on the Twitter feed. We've had a lot of you participating in that, but also the invisible audience who's been actively participating in this from far away. We will not only share a written report, but we'll be posting this video for you to take a look at some of the highlights. If you think you have seen or heard something that you'd like to go back and listen to again or share with a colleague, this will be posted, not just on YouTube, but on the World Smart City website. We will share that report of summarizing this there as well, but most importantly, we're asking for your suggestions about next steps. We've heard over the course of today, during the lunch, during the coffee breaks, via Twitter and some email messages I've also received, we've had some very good suggestions about what to do next to keep this conversation alive, not just at ISO and ITU and especially at the IEC, but to keep it alive amongst us in this community. And we built a community website, so you'll see there's a forum there with blog posts and with other channels for communication. And you're invited to spend time there and give us your feedback. But most importantly, you may have a specific suggestion that we should take this conversation to Latin America or to Africa or to other parts of Asia or North America or Europe or wherever you think geographically this conversation should be replicated. Or it may be that we need to take it in a new direction, that we didn't really focus enough on the human factor, or we didn't focus enough on the existing standards and how they can be improved, or any of the areas that you think we didn't give enough time to. But we really ask your involvement because we depend on you to give us your insights. We didn't hear enough from you, and that's just in the normal course of this kind of a discussion. And we say thanks to you for participating in this. Thanks for you for being engaged. Thanks to all of the panelists that we've had who've come from around the world. And they've spent time and money and their intellectual capital with us. Thanks to our primary organizers at the International Electrotechnical Commission and to their partners at the International Standards Organization and the International Telecommunications Union. All that brainpower in Geneva coming here to Singapore has been fantastic. Thanks especially to the IEC's two staff leaders, Gabriela and Peter, who have really put countless hours and days and months into this effort, and the staff behind them who have really worked very hard. You haven't met Sylvia, for instance. Sylvia, I think it's important for you to wave and let us know that you're alive and well. She's been tweeting the whole time. Thank you so much to Jean and to June and their staff who have been invisible in black back there. Everybody who's been wearing black actually works very hard, so we really welcome, and thanks to our television crew who's made it possible for us to get the world to be involved in this discussion. A lot of others to thank, but I'll close at this moment by saying you have made this possible. It was organized for you, with you in mind. Tell us where we failed. Tell us if we did succeed in some measure, and we promise to be back to you with much more. So thank everybody. Join me a round of applause.